In this video tutorial, we are going to execute a Monte Carlo simulation using the Grant equilibrium method that calculates vapor-liquid equilibrium data as an example. The description of this method can be found under the displayed link. The GE method consists of two consecutive simulations, one NPT simulation for the liquid phase and one pseudo-Grant canonical ensemble simulation for the vapor phase. We will first simulate the liquid phase. You can refer to the earlier videos for running NPT simulations. A requirement for the NPT simulation is a prescribed pressure P, which should be close to the actual vapor pressure. Also, an initial guess for the coexisting vapor density must be supplied. These are the results of the NPT ensemble simulation for the liquid run. Some outputs of this calculation are required as input to a subsequent pseudo-Grant canonical ensemble simulation. Let us open the ms2 par application to create the input parameter file for the pseudo-Grant canonical ensemble simulation. Select the SI units. Enter reference scales. Length in angstrom, energy in Kelvin, mass in atomic mass units. We are going to perform a Monte Carlo simulation. Enter the target acceptance rate of Monte Carlo moves. Choose the pseudo-Grant canonical ensemble. Enter the number of NVT equilibration Monte Carlo cycles. NVT equilibration is important for obtaining a realistic configuration for starting the production phase. Enter the number of equilibration Monte Carlo cycles in the pseudo-Grant canonical ensemble. Enter the number of production cycles for the actual sampling of thermodynamic properties. Specify the update frequency for the .rav file. Specify the update frequency for the result file or .res file. Specify the update frequency for writing configurations to the Vim file for later visualization purposes. No Vim file will be created if the entered value is 0. Enter the temperature, the density, and the number of particles. Enter the corresponding results from the NPT liquid run in these columns. The initial pressure of the NPT simulation should be entered in the pressure 0 box in SI units. Enter the NPT simulation results in two columns. First column, density, enthalpy, isothermal compressibility, and the pressure derivative of enthalpy at constant temperature and composition. Second column, all corresponding uncertainties. Please note that all results must be in SI units. To specify a molecular force field model, upload the respective PM files. Let us use the oxygen potential model file as an example. Enter the molar fraction of oxygen molecules. Add an acetone potential model file. In this example, an equimolar composition is chosen. Enter the binary interaction parameters eta and xi of the modified Lorentz-Berthelot combination rule. Click here to enter the GE parameters obtained from the liquid run. Enter the mole fraction in the liquid phase. Enter the numerical results, including errors, for the chemical potential and the partial molar volume in reduced units. Click on the Calculate Max Cutoff to determine the maximum cutoff radius. The dielectric constant for the reaction field medium can be entered here. Save the PAR file you created. Give it a name. Run the simulation using the PAR file and the ms2 executable. You will then see the following output files. Thank you for watching this tutorial.